Okay, good morning. We're going to do 2.2 length of a line segment today. And of course, it's the length of a line segment, not the length of a line, because the length of a line has an infinite length because it goes on forever. So by the end of today's lesson, you should be able to understand the formula for the distance between 2 points. And I will use the formula, you will use the formula to solve problems. Okay. So the distance between any 2 points, A and B, in the coordinate plane is given by this formula, d equals x2 minus x1 squared plus y2 minus y1 all squared, or delta x. Remember, you might have seen this before. Delta just means change. It's a Greek letter, and it means change. So it's a change in the x's squared plus the change in the y's squared, and then you're taking the square root of that, of course. Okay, let's just take a quick second to maybe see if we can understand this formula. And if we look at, we've got this line segment PQ here, and we're just arbitrarily assigning the letters x1, y1 to this coordinate, and the letters x2, y2 to this coordinate. And if we drop a perpendicular here, and we draw a right triangle formed, and the hypotenuse is PQ, then we can see that at the corner here, this vertex, we can call it whatever we want, let's call it M, is going to have the particular x and y coordinates. So if we look at the height here, the y's are going to be the same as this one. So this is going to, we can call it y1, because whatever this y value is, because it's a straight line here, this is going to have the same y value. And if we look at the x's, this has gone over the same distance from our y-axis as this has, so this is going to be x2. And if we look at how we calculate the length of this line, we know that this is the hypotenuse of the right triangle, and we know, using Pythagorean theorem, that we can just find the length of this side and square it, the length of this side and square it, and then take the square root of that. So when we're looking at finding the length of this side, it's really just the difference in the y's, right? So this would be like y2 minus y1. And over here, this distance here is just whatever the change in the x's is, and that would be this one minus this one. So x2 minus x1, or delta x. So now that we have an expression for the length of this MQ, and we have an expression for the length of MP here and here, we can just use that, right? We can use those expressions, and we can use the Pythagorean theorem to come up with the equation. So that's why up here, when I'm going to take this squared, the sum of the squares, remember, of the other two sides is equal to the square of the hypotenuse. So this squared plus this squared would equal PQ squared, and then we would take the square root of both sides to get PQ, which is D. D is the distance from P to Q. All right, so that's the distance formula explained. Let's see if we can use it in some examples. Now let's just go quickly through what is sort of prior knowledge here. A line segment is a part of a line between two specific points, including the points themselves. Check. You should know that. The slope of a line segment is the same as the slope of the line containing the line segment. Check. You should know that. Parallel line segments have the same slope. Again, we've discussed that. Perpendicular line segments have negative reciprocal slopes. You know that from last lesson. A scalene triangle has 3 different side lengths. You know that. An isosceles triangle has 2 equal side lengths and 2 equal angles. So sometimes the angle part some people have difficulty with. So if these two sides are the same length, then their opposite angles are the same as well, the base angles. Okay, so that's what that one's saying. An equilateral triangle has 3 equal side lengths and 3 equal angles. Check. A right triangle, has a 90-degree angle, and therefore 2 sides are perpendicular. Check. A parallelogram is a quadrilateral with 2 pairs of parallel sides, and you should know that. You should also remember slope is rise over run, and the slope formula is y2 minus y1 over x2 minus x1. Alrighty, here we go. Find the length of each line segment with the following endpoints. I'm just grabbing my calculator. I think I'm going to need it. All right, so I'm just going to write DAB. So it's the distance of line segment AB is going to equal the square root. I'm just going to write the formula out for you. And it doesn't matter whether you write x1 minus x2 or x2 minus x1, as long as you're squaring it. And you're adding those together. Remember, you can relate it back to Pythagorean theorem if you forget. It's the sum of the squares, remember, of the two sides. All right, so if we're calling this one x1, y1, and this one x2, y2, and I didn't have to, but I arbitrarily did that, then this is going to be 4 minus 7 squared plus minus 5 minus 1 squared. All right. This is negative 3 squared, and a common mistake would not to use the brackets here, so make sure you're putting that negative 3 in a bracket, and then plus negative 6 all squared. Well, that's going to equal positive 9, regardless of what your calculator is telling you. Okay, a negative squared is always a positive, so don't trust your calculator if your calculator is lying to you. All right, and that's 36, so this is going to be the square root of 45. Now, it didn't say find the exact length, but this would be, the square root of 45 units would be the exact length, because we wouldn't, if it didn't come out to a nice number, we could leave it like this, or we could simplify it. And, oh, I don't know that you haven't learned that yet, sorry, so we won't do that yet. So we can leave it as the square root of 45, or we can calculate the square root of 45. So the square root of 45 is approximately, and we'll just give it to one decimal place, so that's 6.7 units, and that's the approximate answer. Okay, so depending on what I'm looking for, whether it's a word problem, if it's just calculating it to check on some lengths, then you might leave it as the square root of 45. You'll see as we go along where it's appropriate to find the exact value and where it's appropriate to find the approximate value. All right, in this next one, I want you to pause the video now, and I want you to calculate this one, please. So D of PQ, that line's not supposed to be there. Okay, D of PQ is equal to the square root. I won't put the formula in this time. Minus 3 minus minus 3, tricky. That's a 3. And then plus 6 minus minus 2. So really be careful with those integers, please. Minus 3 minus minus 3 is actually 0. It's minus 3 plus 3, so that's just 0 squared plus 8 squared, which is 64, which is 8 units. Exactly. We didn't have to consider the approximate value there. Okay? Tricky with the negative negatives, so you really do need to be careful about that. Okay. So a triangle has vertices A, B, and C. Draw A, B, and C on the grid and find the lengths of each side. So super easy. So negative 1, negative 1. Again, you can do this if you'd like. If you want to pause the video and then see how you do, feel free. If I'm asking you to draw a triangle, and it's very difficult for me to do that, then you want to make sure that you've labeled your coordinates, okay? It's really important that you label not just the letter, but the coordinates, because you're going to be using them a lot. And you're going to be referring back to the graph. So put them on the graph, please. Okay, find the lengths of each side. So the distance of BC, for instance, is going to be the square root of 2 minus 1 squared plus 0 minus 3 squared So that's 1 squared, which is 1, plus 9, which is the square root of 10 exactly. So I won't bother finding the approximate value. D of AB is going to equal the square root of negative 1 minus 2 all squared plus negative 1 minus 0 all squared. So that's going to be negative 3 squared plus negative 1 squared. A couple steps here. And oops, ran out of room, which is equal to 9 plus 1, which is the square root of 10. Okay. I'm also going to find the distance of AC, and that's going to be the square root of negative 1 minus 1 squared. Sorry, shouldn't have had that. So that's negative 1 minus 1 plus negative 1 minus 3 squared. Negative 2 squared plus negative 4 squared. Okay, so we've got the square root of 20 units. I should put units here too. Okay. So the distance of AB is the square root of 10. The distance of AC is the square root of 20. And then the distance, determine the perimeter. So the perimeter is just the 3 sides added up. So that's equal to the square root of 10 plus the square root of 10 plus the square root of 20. Well, you don't know how to add radicals, so at this point you're going to have to change it to decimals. So I'll just square root of 10 is approximately 3.16 plus 3.16 plus the square root of 20 is going to be just 4.47. So the perimeter then, 4.47 plus 2 times 3.16 is 10.79 approximately. What kind of triangle is ABC? And so from the lengths, I can tell that the triangle is isosceles. And I'll just write Y as well, because only 2 side lengths are the same. Okay, I had to sort of put the word only in there because if just 2 side lengths are the same and you don't know the third side length, you can't conclude that it's isosceles. So you use 2 different methods to determine whether ABC is a right triangle. Okay, well, let's just go back and look. Triangle ABC looks like it might be a right triangle. It looks like it might have a right triangle or right angle right there. So I'm going to say that if I know that this length and this length are the same, but that's not helping me to determine whether it's a right triangle. The only way that I can confirm that it's a right triangle is if this slope of this length here, this line here, is the negative reciprocal of the slope of this line. If we can prove that, then we can prove that there's a right angle in that corner there. So we need to find the slope of BC and the slope of AB. I'm going to have to refer back. So slope of AB, I'll just write the formula down to refresh your memory. So AB would be 0, minus, minus 1, and 2, minus, minus 1. Which is 1/3. The slope of BC, go back and have a peek at that. I won't write the formula out for that one, but the slope of BC is 0, minus 3, and 2, minus 1. Negative 3 over 1. So, the slope of BC is perpendicular to the slope of AB, right? We can just say because, let's put a therefore statement there. Therefore, the slope is because the slopes are negative reciprocals of each other. So always justify why you're making that conclusion. But you know what? That's really not what our conclusion is. Our conclusion, so I'm gonna renege on that therefore statement. So that's kind of a conclusion that we've made from this calculation. Therefore, we could say since, let's use the word since, or reneging again. Since two sides are perpendicular, a triangle must be a right triangle. Okay. Running out of room, but I'm going to do that second method now. So I'm just going to, So the second method of determining whether this triangle is a right triangle is to use the Pythagorean theorem. So the Pythagorean theorem says that the hypotenuse squared is equal to the sums of the squares of the other two sides. Well, we have the hypotenuse. That was let me just get that right, AC. So this is like saying AC squared is going to be equal to A squared, which is one of the other two sides, right? B squared plus AB squared. Well, we have those lengths. So this was the square root of 20 squared. With BC, we calculated to be the square root of 10 squared, and AB the same. So if we can prove that this is true, that left side equals right side, then it has to be a right triangle. So the square root of 20 squared, well, it's the square root of 20 times the square root of 20, really. This is the square root of 10 times the square root of 10, twice. The square root of 20 times the square root of 20, if we do it the long way, it's the square root of 400. This is the square root of 100, and this is the square root of 100. So this is 20 equals 10 plus 10 when you actually calculate the square roots. And you get that 20 equals 20, and left side equals right side. And then therefore, since the Pythagorean theorem, we could say holds or is true, the triangle must be a right triangle. Okay? All right. Determine the area of ABC. All right, so we know that this is a right triangle, so I'm just going to reproduce it here. To find the area of a triangle, so this is A, C, D, I believe. We just find the formula for the area of a triangle, so the area of ABC is going to equal base times height divided by 2. So if we're looking, when it's talking about base and height, it has to be a perpendicular relationship to find the area. This one luckily is a right triangle already, so we just have to take the length of this one and multiply it by the length of this one and divide by 2. Well, we already know the length of those. This one was the square root of 10. This one was the square root of 10, and we're going to divide that whole thing by 2. The square root of 10 divided by the square root of 10 is just 10, remember, over here. So when you're taking the square root of something squared, all you do is just take that number out of the radical sign, so it would be 20, right? So that's what we're really doing here. So we get 10 divided by 2, which is 5. And in this case, we would say, if we didn't know what the units were, which I don't believe we do, we would just use units squared here because it's an area. Okay? All right, so that's the area of A, B, C. All right, a couple more problems. This is a long lesson. An airplane at coordinates 150, 136 is headed for Sudbury, which is located at 0, 0. The airplane has to be diverted due to poor weather conditions. The plane can either go to North Bay at 85 minus 10 or to Timmins, which is at negative 10, 155. If the plane has only enough fuel to get to Sudbury, which alternate airport would be safer to head for? So really all this is asking you to do is to find the distance from the current location of the airplane to North Bay and to Timmins, and to double check how much fuel it had to begin with. So we're going to also have to find the distance from the airplane to Sudbury. So right now, if we just say distance to S for Sudbury, that's fine, as long as you can sort of communicate to me what you're finding here. Just don't put D equals for all three of your calculations because I don't know which calculation it refers to. So D equals S, or DS equals the square root of 150 minus 0, which is just 150 squared, plus 136 squared. So I definitely need my calculator for that. So 150 squared, that's 22500 plus 136 squared is 18496. All right, plus 22500. So that's the square root of 40996, which is equal to 202.47 units. So we don't really need to find the exact value here because we're just going to compare the lengths, but I went ahead and did it anyway. I have to put an approximate sign there. So that's the distance to Sudbury. Let's find the distance to North Bay. So the distance to North Bay is going to be 150 minus 85 squared plus 136 minus 10 squared. Okay, so the distance to North Bay is 150 minus 85, which is 65 squared, plus 136 plus 10, so that's 146 squared. So the distance to North Bay squared plus 65 squared. And then just add that together and get 25541. So I'm looking here right off the bat, and the square root of 25,541 I know is going to be less than the square root of 40,996. So I know right now that I have enough fuel to get to North Bay. Okay, let's find the distance to Timmins. So that's going to equal, again, 150 minus 10 squared plus 136 minus, where's Timmins? Minus 155 squared. Make sure you're covering your entire number there with the radical sign. All right, so the distance to Timmins is going to be 160 squared plus 136 minus 155 is minus 19 squared. So the distance to Timmins, when I add those together, is 25961. All right, I can get to either place because the distance to Sudbury is far greater than distance to either of these two. But if we're talking economy, they're going to want to go to the closest airport, obviously. So you could say something like, therefore, they have enough fuel to get to either North Bay or Timmins, but it would be cheaper to go to North Bay. Okay, notice how I didn't bother calculating the actual approximate distance in units because I just bothered to look at the square root values, which are exact. So it's one less step. You can certainly, if you're more comfortable, you can calculate the approximate values and use those as your comparison. But because it didn't ask for the number of miles or whatever the units were, I can feel comfortable just using the radical values. Okay, determine the length of the median from vertex P in PQR with vertices wah wah. All right, round answers to one decimal place. All right, well, the first thing I would suggest you do is you graph it here to get your visual. So minus 5 minus 6 is P. Q is minus 1, 2. And R is 7, negative 4. Okay, so I'm going to do my best to draw this triangle. Not easy with this tablet that I use. Ignore that. Okay, so now I need to draw a median from vertex P. So let's do that in red. Where's P? Here. So I'm going from here all the way over. I'm meeting here at point M, and I know that I have created equal parts here, so I bisected QR. Okay, so it says determine the length of the median. Okay, well, if I want to find the length from P to M, I need the coordinates of M. And I can do that very easily by knowing the properties of a median. We already talked about how it bisects, right? So I need to find the midpoint of QR. So capital M, QR. Remember the midpoint formula? I'll just refresh your memory. x1 plus x2 over 2, so it's the average, remember, of the y's, the average of the x's. All right, so add those together, so that's 7 minus 1 over 2, and minus 4 plus 2 over 2, which is 3, and this is minus 1. Does it look like 3 minus 1? Sort of. Okay, so I'll write those coordinates in, and now I need to find the distance of PM. And of course, just refresh your memory, x1 minus x2 squared plus y1 minus y2 squared. All right, so this is 3 minus 5, whoopsie, square root of 3 minus 5 squared plus minus 1 minus 6. Ugh, I keep doing that. Sorry, ignore that comma there. Here, I'll fix it. Okay, so minus 1 minus 6. No, sorry, minus 1 minus 6. So minus 6 squared. So when we sort out all our minuses here, we end up with 8. So this is the square root of 8 squared plus, this one's tricky, minus 1 minus 2. 6, sorry, minus 1 minus 6 is going to be minus 1 plus 6, which is 5. So this is equal to square root of 64 plus 25, which is the square root of 89. And so the distance from PM. So if it asks for the exact distance, I could just leave it like that and just say units. So it's asking for the length. Oh, round answer to 1 decimal place. So I'm going to go ahead then. I've got permission to give an approximate answer here. So the distance of PM is approximately equal to 9.4 units. Okay. Did I answer the question? Determine the length of the median from vertex P. Okay, done. All right. I'm thinking that might be the end of it. Yeah. All right. Have a great rest of your day. Just please finish do the homework for 2.2, please. I have given you the handout, and it's posted on the website if you don't have the handout. Thank you.